still called RH. And once they did figure out which one that was actually pointed at, they called it the antigen LW after Landsteiner and Viner. But like I said, the RH designation stuff, even though that's the wrong antigen, we'd already been calling it RH long enough by then that that's just the way it was. In 1939, what had happened, it was an OB patient. She delivered a stillborn baby. She needed a transfusion, and her husband was the same ABO type. So they gave her his blood. When that happened, she had an acute hemolytic transfusion reaction. Then they isolated the antibody from her. So remember how we mentioned a time or two here and there that you can produce anti-D through transfusion or through pregnancy. She had developed that during pregnancy and then reacted to her husband's blood because they were not RH compatible at that point. They didn't know that existed then.
Bless you.
Thank you.
In blood bank, after ABO, the RH is the most significant antibody system or antigen system that there is. By the mid-40s, they discovered 5 different antigens in the system. Today, there's more than 50. When I say that when we're talking about blood type, blood group antigens, there are hundreds of them. That's literal. There are literally hundreds. Most of them just aren't significant. Of the ones that are significant, D, big C, big E, little c, little e. Notice they're all in pairs except for the D. There is no evidence that little d antigen exists. It is often written as a placeholder just for convenience. Antibodies to any of these big 5 can cause transfusion reactions and hemolytic disease in the newborn. But that term RH positive, even though we've already discussed that RH is over 50 antigens, over the years it's just going to mean if you say RH positive, you're speaking of the D, not of the rest of them. And that's a problem with language. That's just kind of like still calling it the RH group, even though it has nothing to do with Reese's money. Just one of those things. In blood bank, routinely we only test for the D. We only start testing for C or E or any of those others if we discover an issue. Then we'll start looking deeper. So this is the part I hate. You're going to hate it too. While I'm talking about this, this is kind of covered at the bottom of page 126. The current theory of the inheritance of the RH blood group system is 2 closely linked genes. There is an older theory called the Fisher race, which was 3 different loci. And then Viner thought that there was only one locus. He said one locus was responsible for all of these designations. So the difference between Fisher race and Viner, Fisher race was 3 genes, Viner was 1 gene. We now believe it to be 2. So why do we care about these other ones? Because in the world of modern medicine, people like to use them interchangeably. Because they had the way it was written in the designations for the inheritance of this. Oh, I added that slide. That makes it easier. That'll be on the first one. All right. To make this as easy as possible. Someone who has the D antigen does not have C and E. Big C, big E, but they have little c, little e. That's written as that. Lowercase c, big D, little e. The Viner terminology for that is an RO. And you can see the difference between all those. The easiest way I know to remember this, if you see capital R, they have the D antigen. If it's lowercase r, they do not have the D antigen. You will also see people write this with a lowercase d, CE. That is not proven to be correct, but people do it for convenience. It is not done that way in your book. Yeah.
We should absorb all of this for the upcoming exam, correct?
Yes. And I will promise you they will do this to you over and over and over on your registry. R1, they have big C, big D, little e. R2, RZ, etc. These tacks by the little r here, that's R prime and R double prime. And that is going to be strictly a memorization thing. I don't know any other way to put that through your head. Because in normal routine blood bank, are you going to use this? Not very often. You're going to get weird calls from ABI. Say, hey, I need an R1 unit. You got one? I don't know, what's R1? You're going to get these weird calls. So you have to know them. Luckily in the lab, Google's your friend. No, you may not use Google on your exam.
Did you ever see any of this when you were in blood bank?
Do what?
Did you ever see any of this stuff or get calls about it?
Yes, but not terribly often. Why they still force this outdated stuff down our throats is beyond me, because we've already proven that both of their theories are incorrect. And yet we still continue to use them.
That's ridiculous. Welcome
to the modern world. We've proven that Apple computers are garbage too. People still buy them every day. So the Rh antigens are co-dominant. Patient with a phenotype, big C, big D, big E, little c, little d, little e, would express all of those antigens. So they're co-dominant. If you have big C and little c, it's not like blood types where you just express like type A or whatever. You're going to express both of them. They're all co-dominant. Rh antibodies are acquired, not naturally occurring. It's just like, think about the D in the blood types. If you don't have the D antigen, you do not automatically have anti-D. This is not in the ABO group. They have to be induced, either through transfusion or pregnancy. Patient with a homozygous phenotype, big C, big D, big E twice, could build anti-little c and anti-little e. So if you're exposed to blood that doesn't correspond there, you can build an antibody to the antigens that you're missing. There's another one called Rh null. This is the complete lack of Rh antigens. This is not normal. It's a defect. It causes red cell membrane abnormalities and shortened red cell lifespan. So that occurs very, very rarely. These people are not going to have a long life. That last part, the Punnett squares, you know how to do Punnett squares a little bit from the ABO thing. It's the same thing. It's just using the using this CDE code.
Somebody's RH can't receive blood, can they? I mean, when they have.
They can, but they're almost sure to react to whatever they get.
They would have
I have no fucking idea what he's talking about.
But if you had the two parents that it's mentioning,
What is this called again?
and here I am writing the little d just for convenience.
RH groups?
Well, you fill it out the exact same way as far as the possible genotypes of their children. Unlike the ABO, as far as knowing like you're type A, knowing whether you're AA or AO, it's kind of hard to do. This you can figure it out. Because there's anti-sera for all of these. So if you test your red cells for all 5 of these anti-sera, you're gonna know exactly which antigens you have. You would know your actual genotype for the RH antigens. You can't do that with like A, or AO. You can for this. So let's say you were positive for all of them, all 5. You would know that you were the example, the second one there. Big C, big D, big E. I'll turn that back on.
Where are we at?
On the PowerPoint.
Sorry.
Oh, that's right.
I'm sorry. I just thought you turned it off. I'm sorry.
I did turn this off, but I told it to come back on and it's line. Because that button says it's on, but visually we can see that it was not.
Right.
Well, you know, computers.
Which is confusing because unless I look at that from here, that says on and I have a screen. But,
We have nothing.
yeah, no.
And
Oh.
showtime.
Alright, like the second one up there. If we test your red cells for all 5 of these anti-sera and all 5 of them are positive, that has to be your genotype.
Okay.
Big C, big D, little e. And then whichever ones were negative, you would know which ones you were lacking. So of these, the reason we routinely only test for the D is the most immunogenic antigen in the RH system. If you are RH negative and I give you RH positive blood, you are almost assured of developing anti-D. It is not a maybe, it's not a 50-50, it's more like a 90-10. What percentage of the population is RH negative?
95.
RH negative, about 15% roughly. About 85% of the population is RH positive. It says there, it says 85% of D negative people receiving D positive blood will produce anti-D. I bet it's higher than that in reality. You're almost assured of it. And again, just like doing blood types, how do we detect the D antigen? We use anti-D reagent. When the D antigen is weakly expressed on red cells, its detection requires the use of incubation and the addition of AHG, or Coombs. So if it's weak or it's negative and we're not sure about it, we can incubate it and make it stronger. If we're still not sure about it, we can add Coombs and make it even stronger. And if it's still negative, well, they're negative. We generally will only do that on a pregnant woman. Because anybody else, if they have a D that week, we don't care because we're going to give them negative blood anyway. It's not that important, but on a pregnant woman, it becomes very, very important. So we'll start looking for that weak D, if it's there. And it goes on to say, if it's very weakly expressed, it's referred to as weak D. The old terminology, and you'll still see it occasionally, is the DU, which just means weak D. It means they have the D antigen, it's just very, very weak, almost undetectable. Sometimes it is undetectable. This can be caused by a couple of different things. Some people, their genetics are encoded to form just very few D antigens on their red cells. Some people have the right number of D antigens, but there's like a fault. Something's out of order or something, so everything doesn't bind like it's supposed to. That's neither here nor there. What you need to know is that occasionally, a small percentage of people that have that D antigen will be very, very weak, to the point it's almost undetectable. So we have to take steps to strengthen that, primarily in pregnant women or newborns. Everybody else, we don't care. If I test Bianca on immediate spin and shake it out, and she's O negative, I won't give her O negative blood. So if she's weak D positive, and let's say she's really O positive, and I give her O negative blood, no harm, no foul. The only time it's an issue is if she's about to have a baby, and we need to know if we need to give her a shot of Rogam or what.
Right.
Then it becomes very important. So for the weak D, the genetic weak D is just quantitative. They just don't have very many D antigens. It's just hard to pick up. The position effect is difficult to explain. When the big C is inherited on the opposite side from the big D, there's something that occurs there that makes that D react weakly. They don't even understand it, but they call it position effect weak D. And it goes on to say it's as if the C antigen weakens the D antigen. They don't understand it entirely. The partial mosaic D. This is the structural defect. You notice I said the antigens are composed of like a long chain of sugars. One of the sugars in the middle of that chain somewhere is missing.
Okay.
So the part that's important on the end is there, but something's missing in the middle, and the antibody can tell the difference. So it just doesn't bind very well to it. It realizes that that kind of looks like a D, but there's something wrong with it. So it binds, but not as well. So they call it a partial D or a mosaic D. It's missing a couple of pieces that it needs to be a complete D antigen. So there's genetic weak D. It's exactly what I said. Genetic weak D, they just don't have as many D antigens as a normal person. So as a result, you're going to get a much weaker reaction out of it. And this is something, this is the C being inherited with the D, and it puts the antigens close together, and there's some sort of interference. Then the mosaic. This is showing it as building blocks and not a chain of sugars, but the same thing applies. You have the D antigen, and the partial D there's a piece of it missing. The important parts are there. It's still recognizable as a D antigen, it's just not complete. So it just doesn't bind as well. So the significance of weak D testing. ABI does it. They have to know on donor red cells, is this truly a negative or a positive? So they have to do it on all negative units. Even if they're weak D positive, and it's super, super, super weak, it is still there. That is still an Rh positive unit, will be labeled as such. Inclusion of a control is important to verify a weak D positive result. It is not due to the patient's positive DAT or direct antibody test. If the patient has something going on and there's antibodies already on their red cells, that's going to show up in your weak D. You need to know, is that really showing up in the weak D, or is that showing up everywhere? So you have to run that control, and it has to be negative for you to take the results. Testing for weak D on recipient samples is not required. A patient who is D negative and classified as D negative will be transfused with D negative blood. So everything's fine. Even if they're really positive, it's not going to make any difference. Except, like I said, very last line, weak D testing is done on Rh negative mothers and babies. Because we need to know, does that mother need Rogaine? There is some debate on whether or not to do weak D testing. Some of your real old school techs will do weak D testing on everyone they get that's negative. There's some argument to be made there, because that way we're not giving like O negative units to people who are really O positive. Maybe there's some validity there, but no newer tech's going to do that. If I get negative, I'm giving them negative. I'm not going to sit there and weak D everyone I get that's negative. The important ones, yes, mothers and babies. So compound antigen. You just need to know about the existence of this. It's a distinct antigen produced when two other antigens are encoded on the same gene. Biggest example of that is when little c and little e are inherited together on the same chromosome, they will form a little F antigen.
Oh my God.
The little F can elicit its own immune response. Once it's there, it's not dependent on the others. But for it to be formed, that little c, little e, gotta be on the same chromosome. And that's all I want you to know is that little F, you gotta have little c, little e. The G is similar, but it has to do with big D, big C. And I actually had a G in the last 6 months I worked in the lab. And how you deal with it, if you give someone blood that is negative for the D antigen, so a negative unit, and you screen it for big C, you're good. Because if that's negative, that unit cannot have the G. Because you can't buy testing sera for the G antigen. So the only way you can test for it is to test for these two. And if they're absent, that has to be absent. That's just like if you were to test a unit for little c, little e. If it's both negative, well, you don't even have to test for F. It's not there. It can't be there. You can't get little f testing material either. So you have to do it backwards like that, yes.
Okay, so F requires C and E.
Little c, little e,
Sorry, right,
Yes.
little c, little e, and G requires D and big C.
yes. Unusual phenotypes, the Rh null, complete absence of all Rh antigens. The only thing you can transfuse them with without having some sort of problem is Rh null blood. And that's going to be about as easy to get as Bombay phenotype. It's going to be one of those special units you order that they keep frozen just for these scenarios. I've never experienced it. I've never talked to anyone who's experienced it. I don't anticipate y'all ever experiencing it. You just have to know about its existence. Whereas Bombay is complete absence of ABO antigens, Rh null is complete absence of Rh antigens. The D deletion, chemical reactions in the body can delete antigens that should be there. I'm not going to require you to know anything about D deletion. Rh null, you need to know they have no Rh antigens, and that's about as deep as I want you to go into that. It exists. You've heard of it now. So most Rh antibodies are acquired through transfusion and/or pregnancy. Most, should be all. Most are IgG, which means what?
They can close.
Most of them you cannot detect on immediate spin. You have to add the green stuff. You have to incubate. You have to add Coombs, antihuman globulin, whatever you want to call it. They bind at 37 degrees. They react best in a high protein matrix, such as HG. You can have a few Rh antibodies that are IgM. The biggest example, anti-D. It reacts just fine at immediate spin without incubating. It tends to be, a large majority of it tends to be IgM. These others will not. If you get something with a anti-big C in it, it is not going to show up at immediate spin. Most show dosage. More on that in a second. They will cause severe transfusion reactions, hemolytic transfusion reactions. Start lysing their own blood, peeing hemoglobin. It's a bad scene. Since most of them are IgG, they can cross with placenta, which means they can cause hemolytic disease of the newborn. Start destroying the baby's red blood cells. Babies born anemic, bilirubin through the roof, can be fatal in severe cases. Can be enhanced by enzyme-treated red cells. We've mentioned that briefly. Treating red cells with enzymes, it enhances some antigen and destroys others. The Rh are enhanced. They show up stronger. again, the most important thing about RH antibodies, they can cross the placenta. Well, we're so concerned about them with mother-baby reactions. So, we got a whole chapter on hemolytic disease of the newborn. We're gonna touch on it briefly here. Any antibody that is IgG theoretically can cause hemolytic disease of the newborn. An initial pregnancy stimulates the mother. In this case, they're using anti-D because that's the most severe. So mother's, say O neg, has a baby that's O pos, doesn't get ROGAM, she develops anti-D. No problem. She can have anti-D and be just fine. What happens when she has baby number 2?
That's whenever it can be a refill.
Now she's got anti-D in her system. A portion of that will be IgG. If that baby, the second baby, is Rh positive, those antibodies will cross the placenta, will attack the baby. Worst case scenario, the baby's going to be born stillborn. Best case scenario is going to be born extremely anemic with a bilirubin through the roof to the point of near brain damage. They're going to be fighting to bring it back down. That's why ROGAM is so important. That's why getting that D2 correct on pregnant women is so important. So we talk about ROGAM. Number one, what is ROGAM? ROGAM is nothing in the world but an injection of anti-D. Because when that mother-baby blood mixes, if you give her an injection of anti-D, it will bind to those baby cells. Mother's body will see that, and it says, wait a minute, that's an Rh positive cell, but, oh, it's already got an antibody on it. It's good then, don't worry about it. She will not produce anti-D, because the body recognizes there's already an antibody there, so it won't produce the antibody.
Was it almost like a vaccine?
Almost. It's only temporary. But by doing that, the body recognizes, oh, that's a problem, but it's already being dealt with. We don't need to produce antibodies. That's what ROGAM is. It's nothing in the world but anti-D. We're jumping the gun and putting anti-D on those cells before mother's body can. And that's why it has to be given within the first couple of days of birth. He goes on to say ROGAM, or RHIG, is a modified, purified anti-D. That's all it is. Unfortunately, it does not protect from the other ones. The big C, the little c, the big E, those. But the most immunogenic of the bunch is the D, and that's the one we can protect. So qualifications for ROGAM. Number one, mom must be D negative. If she's D positive, she's not going to produce anti-D anyway. She'll destroy her own cells. Baby has to be D positive. Because if mother's negative and baby's negative, well, even if their blood mixes, there's no anti-D going to be formed. There's no D antigen to stimulate it. So mom has to be negative, baby has to be positive. And that's why, in those circumstances, that's why we do the weekly testing. We want to be sure. If that tube comes out negative, we're going to incubate it. We're going to look at it again. If it comes out negative, we're going to add Coombs and we're going to look at it again. We're going to do everything we can to detect the D antigen if it's there. Most of the time, when it comes out negative that first time, it stays negative. You don't find a lot of weak Ds. They're out there. It's not super rare, but you don't find them. But you still, as a precaution, want to go through all the testing. So think of that ROGAM, it's a preemptive strike. We'll destroy it before the antibodies can. Isn't that chapter fun?
Yeah.
Oh, it's garbage.
Yeah, I was gonna say it's very confusing. I wasn't sure what I was listening to.
Like, up until this point, I understood blood bank. That was a bad chapter.
No, not yet.
Not yet.
Oh, no.
I don't like the sound
All right, I mentioned dosage.
Mm-hmm.
And I'll use C as an example. Big C, little c. We're testing the patient for both of these. If big C is positive and little c is negative, let's give it a 4+. It'll never be that strong. And if this one is positive and that one is negative, let's say 4+. But if both of them are positive, it can change your reaction. Usually stronger. We'll actually change these. When they inherit together, sometimes it'll do that. Sometimes it'll go the other way. That's what they mean by dosage. When they're together, they're so closely related, they start affecting your reactions. Same thing happens for E.
I have no idea.
It does not happen for D because they've never even proved the existence of that.
Why is it even put in place? Or just leave out?
Convenience, because when you're writing genotypes and you're doing, that looks weird. So I add the little D to it. I don't care either way. I just realized that I know what they have. They've got, if this is their genotype, they've got that antigen, and that antigen. That's what I need to know about it. That's all I need to know about it. So if they was this,
Just watch the video. Oh, you gotta work.
they don't inherit twice as much as big C. They've still just got, they've got big C, big D, little e. That's what's on their red cells.
Do you remember seeing this?
Combination of those.
I'm sorry, I didn't mean to interrupt you. Do you remember seeing this on your registry?
Multiple times. Because what they're gonna wanna know is, they're gonna give you this. What antigens does that person have?
R prime, R double prime.
R1, big R, 1,
Oh,
R double prime.
there. What is it?
So let's break it down. R1,
C, D,
R double prime,
looking at the table.
so the antigens they would have would be, they have the D, they have big C, they have little c,
Let's see.
and little e too. There. That's what they have on the red cells. Yes.
So we're given the big R prime, little r, double prime, as a question on this registry. We'll have some choices. One of the choices will be what you circled.
Yep.
Thank you.
So that chart on the top of page 129 tells you how to convert between Viner and Fisher race.
Use the gene.
Burn it in your brain. Because that's what tells you what is on the red cells.
Who makes up this registry exam? So who makes up this registry exam?
The ASCP.
Demons.
Write a letter to the president.
The table I told you to correct on the bottom of 130 tells you how to test for this using the 5 antisera. So if we wanted to know and test this to figure it all out, we have
I guess
anti-D,
that's it. What the fuck is all this? Oh my
we have
god.
big C, big E, little c, little e. So if that's positive,
Okay.
negative, positive, positive, negative. We can break this down and we know that they've got, they like to put C first for whatever reason. They don't have big C,
So these
little
that are,
c,
so these that are negative are little whatever.
yeah. So using these 5 ancillary, we can actually tell what you've got.
Okay.
And all this is, we're testing to see what antigens are on your red cells. There are hundreds of antiserum. This is just the RH group. And we're only talking about 5. This one, you should already know more than you ever want to know about that one already. You've only got to learn 4. If any of this has a capital R or a big D, they've got this. No matter which way you look at it. Well, that part you know. You just got to learn the rest of them. Biggest thing to remember, D is the most immunogenic. It's the most significant for mother-baby reactions. It can be fatal. That's why we test for it so heavily. None of these will be produced naturally. They've all got, these antibodies all have to be stimulated in some way. Whether I give you into the blood or you have a baby, that's the only way it's gonna happen. It's not like if you're a type A person, you automatically have anti-B. It doesn't work that way. It has to be stimulated in some way. It causes problems because a lot of these tend to be IgG. IgG can cross the placenta. Any IgG antibody can cross the placenta. IgM can't. It's too big. That's why you don't have ABO antibodies just willy-nilly crossing the placenta. It causes problems, killing every baby that's not type specific. Their antibodies are too big. Doesn't work.
Somebody's O negative or D negative, and they're given positive blood, I know you said
They'll develop anti-D.
they'll develop antibodies, then do they have any other type of reaction in their body? I mean, like,
They
feel
could.
sick or
Because even though they're O negative, and all that negative means is this.
yeah, if they're given O positive.
That's still an O negative person. They've got the other 4 of the 5.
Yeah.
Because the only one we test for routinely is the D. So can they still develop antibodies? Hundreds of them.
Yeah.
Can and will a lot of times.
I mean, do they have any type of reaction as if, like, I'm O positive, I'm given your or something
Not the first time.
afterwards?
Not even that. The only time it causes a problem, I don't care if you're sitting there right now with 35 antibodies in your body. You're fine. Until the next time you get blood. That's when we have to start being careful with cross-matching, because then, let's say you develop an anti-big C. We can only give you blood that don't have a big C antigen on it now, because you're gonna destroy it. So the first time, there's no issue.
That's what
It's
you're
the
talking
second time.
about. Okay, so that's what you're talking about in hematology, people who constantly have to receive blood.
Yes, like sickle cell patient,
That's-
because
That's well with that.
they get blood, and you won't develop an antibody every time. Even if this, scenario we're throwing up here, it's not every time, it's most of the time. But they get 3 or 4 transfusions, they develop an antibody. Then they get 3 or 4 transfusions, they get another one.
Okay, so that's why it's so.
That's how they can end up with 4 or 5. One of them at Little Rock, when I was in clinicals, had 7.
Yeah,
What? How many?
7 antibodies.
7?
7.
Yeah, didn't you have to reach out to like one random place in the state to find blood?
Well, we
They
had to
told-
reach
they
out
told you or
to, we
something?
had to reach out to like Red Cross, and they had to go to Colorado.
Oh, yeah, that's what it was. Okay.
That's good.
Because when you start getting multiples, let's say you had a
So that's the only time it's mostly significant?
second time, yeah. That's why, even if I know you don't have big C antigen, if I was working blood bank, I'd give you blood with big C, on it.
What happens if they get all the antigens like Colby's?
If they get antibodies to all this,
Yeah, to the.
you're gonna have a really hard time cross-matching it. But you gotta find a unit that has none of these,
How often does something like that occur?
almost never,
Do you ever see anything like that?
no. 90% of the time in blood bank, if you're dealing with an antibody, it's usually 1. We consider it a huge pain in the rear if somebody has 2 antibodies. We consider it, I quit, I'm going home, if somebody comes in with 3 or 4 antibodies. So usually you're only dealing with 1 at a time. And it's not that big a deal to screen for just say, my favorite actually was this one.
Oh, wait.
Because it's easy to find, it's an immediate spin reaction.
It's easy to find.
It's quick, it's easy. I always like Big E. Let's say if somebody had an anti-Big E, and I had to cross match them, I would pull 3-4 units and screen them, 2 of them would be compatible. So, these really aren't that big a deal, unless you start getting multiples and it's a headache. And that's why we don't routinely screen for them, because no matter what, if I give you 3 antibodies this time, you're gonna be just fine this time. Next time, different story. A story for another day.
But it's mostly for people who have had transfusions in the past and developed antibodies.
Yeah.
I mean, we don't just naturally.
We
have
take it for granted that every single person we give a unit of blood to, the potential is there, they're gonna create an antibody. It just is.
Are they usually tested afterward, like if they're in surgery or whatever? I mean,
We won't test them until the next time they come to the hospital and we have to do a type screen on them, then we'll detect it.
So it's only if they need blood again.
Yeah, so if they don't come back for 5-6 years, we won't know that for 5 or 6 years.
This won't be developed like at birth or something? No?
It can, we won't detect it then. Usually we only detect it when somebody comes back 3 years later for a surgery or they're a routine bleeder or something, then we start picking all this up.
Okay. That was a bad chapter.
No, it's easy, it's worse.
That's what I'm trying to say.
So again, that table, top of 129, pretty important to know. Bottom of 130, pretty good to know. I'm not gonna hit you with equivalent notations,
Thank you.
because it's already bad enough we've got 2 methods here that are completely incorrect. They've also got a numerical system. We have RHO1, RHO4, RHO7, that does the same thing. No, 2's our limit. We're not doing 3.
I don't think I can do 2.
The only reason I do these 2 is because people still use these. Nobody uses the new one that's supposed to be new and improved. No one uses it. It's ridiculous. No one who's been a tech less than 10 years uses these 2. Some of your old school folks, they still like it.
Science is supposed to be all
The
about.
registry still loves it.
Of course they do.
How did you know?
Because it's complicated and stupid.
Do what?
And they need you
How did
to
you
take this
feel
test
like
like 2 or 3 times.
Do you really?
Well, science is supposed to be all about accuracy and precision, like why are they still continuing with this shit that's been proven to be, crap.
All right, let's ask a question.
Okay.
Yeah.
If you discover anti-F in a patient, there is no testing, there is no antisera for anti-F. So what units would you give them?
Well, they're gonna have little C and little E if they have F.
Alright, true.
Okay,
So you just screen for little C, little E, correct?
Yeah.
Good answer. If someone has a weak D, what would you have to do to detect it?
Well, if it's a female that's pregnant, you're gonna incubate it, and then you're gonna add coons.
What is that procedure called?
I don't know.
IAT. Why do you have to include a control when weak D testing?
To maintain quality control and make sure that what you're doing is right.
No, I don't care about QC.
Oh.
Visual?
Because if they've got a positive DAT, which means they've already got antibodies on their red cells, you don't know if what you're seeing is a true positive or a false positive. Just like in that RH control on your type, it has to be negative, otherwise everything's invalid. And that's why we include that, because if that comes up positive, back up punt. It's a problem. What's associated with RH null?
Lack of any RH antigens.
What else? You're right, they have no RH antigens at all. So they're
So
negative.
no antibodies, right? They don't have any.
Yeah. Well, what else?
It's very rare and hard to find blood transfusion. Must have the RH null blood.
Which
Anemia?
means they're gonna die.
Are you looking for anemia?
Anemia,
Yeah.
premature red cell destruction, cell membrane
Short
abnormalities,
Short and life.
shortened lifespan, all correct.
Poor person.
So,
Why is the RH blood group system called the RH blood group system?
because of
It's a
the
mistake.
Reese's
They were testing it with
Reese's, yes.
Reese's monkey cells. They come to find out that that wasn't even the correct antigen. It was a different one. What was the other one?
The L,
That was renamed in their honor.
LW.
LW.
Yeah,
People are stubborn, they should just change it.
I don't know how you pronounce it when it sounds like it's a B when it's obviously it's a W.
I went to German, which means it's a B.
That's
Yeah.
It means Wiener, not Wiener. In America, it's Wiener.
It's
In
weird.
Germany, it's Wiener.
Wiener Schnitzel.
What type of antibodies are most of the RH antibodies?
D,
What type?
D,
That's not a type.
No.
IgG.
Sorry.
Lots of IgG. That's why they're called such a big problem.
That's why I have to cross the placenta.
If you're testing a donor unit,
Mhm.
you're working for ABI, you're testing a donor unit. D comes up negative. You do the weak D and it comes up positive. How should you label this unit?
Positive.
Label it as a positive unit. The fact that it was hard to detect is irrelevant. It's there. It's a positive unit. There's one of those Punnett square questions. Ugh. I don't think there's one of those on your test, but I'm gonna verify. If there is, I'm gonna let you know this week. Because if it is there, I may take it off because I don't like those.
You could just do one fucking like the A and the B and the O.
Didn't write down your slogan?
Right, that's pretty much all I got. And like I said,
Can you have it?
as far as this,
With it?
Viner, Fisher race terminology, tabletop 129. Remember, if it's got a big R, it's got a big D. If it's got a little R, it does not have the D antigen. Other than that, find a method that works for you. Do what? Stuff like memorization. I try not to advocate memorization because it'll almost always get you in trouble. If this is not something you're gonna use on a routine basis in the lab, just be aware, if you memorize,
I don't
you're
understand
gonna have to
any
do
of
it again
this.
before you take the registry. That's the downside of memorization.
Can't need a sheet
It's
and a
plain
sheet.
memorization, so you don't have to rewind it.
Memorization is temporary learning. You know what I did for this stuff for my registry? Memorized it again, then I flipped it.
Sacrificed a goat to save something? What? No, no.
Do I have all these burned into my brain? No, I don't intend on.
Thank you, Jason.